This videotape will show you how to cut internal threads on the lathe. The rules controlling the cutting of internal threads are very similar to those for cutting external threads. However, the clearance restrictions and tool problems of internal thread cutting are more closely related to boring operations. After viewing this videotape, you should be able to write down the safety precautions to be observed in the machine shop and in machining internal threads on the lathe, write down the procedures for grinding and setting up an internal threading tool, and write down the steps in machining an internal thread to a given size and shape. When working in the machine shop, always wear safety glasses. Remove rings, jewelry, and watch. Keep sleeves rolled above the elbows. Run the machine at a low RPM with a minimum amount of tool overhang to prevent chatter and tool breakage in the machining of internal threads. In this demonstration, we will machine a 1" 12 UNF thread in a collar. Larger diameter threads such as these will require a precision fit and are usually done on the lathe. The first step in the machining of internal threads is to determine the minor diameter of the thread. This information is needed so that the hole to be threaded can be drilled and bored to the proper specifications. The minor diameter can vary depending on the class of fit or percentage of thread desired. The minor diameter of internal threads can be determined in a number of ways. The easiest and most common way is to look in the machinery's handbook under the heading of screw threads. For a 1" 12 UNF Class 2B fit, the chart shows a minor diameter measurement of from 0.910 to 0.928. Without the use of a machinery's handbook, the minor diameter can be calculated from the formula minor diameter equals major diameter minus the quantity 1.0262 over the number of threads per inch. By substituting 1" for the major diameter and 12 for the number of threads per inch, the minor diameter is shown to be 0.9145 inches. This figure falls within the range specified by the machinery's handbook. Secure the workpiece in the lathe chuck. Center drill. Lead drill. Then drill a 7/8 inch hole. A 7/8 inch hole, which is 875 thousandths, leaves a minimum of 35 thousandths or a maximum of 53 thousandths to be removed, according to the range specified in the machinery's handbook. After the hole has been drilled through the workpiece, set up the boring bar and bore the hole to a diameter of 914 thousandths, or to a dimension close to midway between the two specified tolerances. Check the finished hole for size using a telescoping gauge and an outside micrometer. When the boring is completed, set up a facing tool and face the end of the work square. Using the same facing tool, machine a 30-degree chamfer in the lead of the hole to allow for easy starting of the thread. This chamfer should be to the major diameter of the internal thread, or in this case, 1 inch. When threads are to be machined to the bottom of a blind hole, a recess should be machined in the part for tool runout. For this demonstration, the threads will be cut clear through, so there is no need for tool runout. Reset the spindle speed to a low RPM, or about 1/4 the speed used for straight turning. Set the quick change gearbox to cut 12 threads per inch. Swivel the compound rest to a 29-degree angle, either toward the headstock or away from the headstock. When swiveled away from the headstock, it will feed toward the operator. Remember that internal threading is just the opposite of external threading, in that the cutting is on the inside of the hole with the tool feeding into the front side of the work. Next, Set up a boring bar with a tool to cut the internal 60-degree form threads. The tool should measure 60 degrees since it will be cutting the thread in one operation. Place the center gauge either against the work or the face of the chuck to align the threading tool. With the tool properly lined up, remove any backlash in the compound in the direction you are going to feed. Use the cross feed and carriage hand wheels to position the tool in the hole and pick up a cut on the minor diameter of the thread. Set the compound and cross feed dials to 0 and then remove the threading tool from the hole. Reset the compound to take a 5/1000th cut. Start the machine and engage the half nut at any one of the division markings on the dial. When the tool has progressed all the way through the work, use the cross feed to back the tool away from the work and remove it from the hole with the carriage hand wheel. Be careful not to hit the back side of the work with the threading tool. Return the cross feed to its 0 setting and shut off the machine. Check the number of threads per inch being cut. If the number of threads per inch is correct, the cutting can proceed. Remember, the compound feed for internal threads is calculated in the same way as for external threads, which is 0.75 times the pitch. The compound feed for this thread will be 64 thousandths. Take another 5 thousandths depth of cut on the compound. Apply lubricant in the hole on the threads while taking continuous passes until you reach the total compound feed of 64 thousandths. As the thread gets larger, reduce the depth of cut of the threading tool to prevent tool breakage and also to produce a better thread. The final finishing passes on the internal thread should be reduced to approximately 1/1000th per pass. When the reading on the compound dial reads 64 thousandths, stop the machine and back the threading tool out of the way. Clean out the threads with a brush and rag to remove all chips and oil. Check the threads with a mating part or a plug gauge. If the thread is not sized to allow the mating part to screw into it, repeat the machining process until the proper size is reached. When the thread is machined to size, remove the part from the chuck and reverse it. Using a facing tool, face and chamfer the other end. This completes the operation of making a threaded collar. Let's review this videotape. When machining internal threads, it is important to determine the minor diameter, as it controls the percentage of thread and class of fit. Internal threading is the opposite of external threading, since the cutting is taking place on the inside of the hole and the cutting tool is fed into the front side of the work. The cutting tool should be carefully aligned using a center gauge, and the compound travel for a proper depth of threads can be calculated by the formula 0.75 times pitch. Internal threads are checked with mating parts or plug gauges. Internal threads are commonly used in machining parts, and the precision of these threads depends upon the skill and experience of the operator.